Welcome to MATLAB tutorials by Civil Thinking, and in this class we are going to talk about some built-in functions in MATLAB. Now before I move on, I suggest you to please watch the video lectures on MATLAB one by one in sequence as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now let us move on to our topic. So what are built-in functions in MATLAB? So what are the built-in functions? So built-in functions are those which already exist in the MATLAB. Okay, so built-in functions, okay, I will write they already exist in MATLAB. Okay, so they already exist, so you don't have to create, like you don't have to create sine of, for example, sine theta function here. Okay, because sine function or any trigonometric function, okay, they already exist. Okay, so you don't have to reinvent the wheel. Okay, so let us talk about these functions. So when we talk about functions, okay, how do we write functions? So we write name of the function. Okay, name of function in MATLAB. I am showing you how to write a function in the MATLAB. So name of the function, predefined function of MATLAB, and in the braces we put the arguments. Okay, argument or arguments. Okay, and when we hit enter we get the output. Okay, so when we hit enter we get the output. Okay, for example, when you write if you write x equals 9, okay, so I have defined a variable and I have stored 9 in this. Okay, now let us talk about function. Now square root of square root, okay, sqrt. Now you remember square root of, for example, 9 or square root of x. Okay, so in MATLAB we write it as sqrt because it is predefined as sqrt. Okay, so sqrt of x when you write, okay, and when you hit enter, so what is the square root of x? Because x is 9, and what is the square root of 9? It is 3, right? So when you hit enter here, when you hit enter you will get the output of 3. Okay, so the name of the function, the arguments, okay, and you will get the output. Okay, so let us see a couple of important built-in functions in MATLAB. So I have already made this table. Okay, now let us try these functions one by one in the MATLAB program. Okay, so let me open the MATLAB program first. Okay, now our MATLAB is open. Okay, so let us practice these. Okay, the first one here is remainder. Okay, so how do we find the remainder of any function, any number? Basically, what is remainder? Remainder is basically when we divide two numbers, for example x and y. Okay, and when we divide the number, when we divide the x with y, okay, so we will get some remainder. Remember, in we get some remainder in division, right? We may get it or we may not get, right? So if you want to find the remainder of division, for example, if you divide 10 by 3, now you want to know what the remainder is, so you will write rem 10 comma 3. Okay, so rem is the function and 10 comma 3 are the two arguments, right? So let us try this in MATLAB. So remainder of, I will write 10 comma 3 and hit enter, and you will get answer is 1. Okay, now you can also do like this. For example, x is equal to 9 and y is equal to 3. Now you can also find remainder like this, rem, in the parenthesis you will write x comma y and hit enter. Okay, and you will get 0. Okay, why you got 0? Because when you divide x by y, when you divide 9 by 3, 9 by 3 is a perfect division. Okay, you don't get any remainder here. Okay, this is the reason you get the remainder as 0. Okay, so let us move on to other functions. Now we have another, so we are done with this remainder. Now we have another predefined function of MATLAB. It is size. Okay, so size basically tells you the size of the matrix. Okay, so I have already talked about this, and let me let us talk a bit here. Okay, now let us say A is a function matrix. Okay, let us say it is first row is 1 2 3 4 semicolon, because with the help of semicolon we create another row, right? And that another row is 3 1 3 3. Okay, so here is our matrix. Now you can see that the number of rows are 2 1 and 2, right? And the number of columns are 1 2 3 and 4. Okay, so the order of this is 2 cross 4. Okay, so if I write size and in the parenthesis I write A, so we got 2 comma 3. Okay, so it means rows are 2 and the columns are 4. Okay, so we got two basically output, but we have two values here. Okay, so sometimes the output have only one value and sometimes the output have two values. Okay, so let's move on to other built-in function. So we are done with this size. Okay, now we can also assign the output, because I told you earlier we have two outputs, right? So we can also assign them to two variables. Okay, so let me show you in the program. So if you write like this, for example, rows comma cols equaled size of A, so you got rows to be 2 and columns to be 4. Okay, so what it does is it basically it stores the the first, this is the variable. Okay, and what is the output of size A? So output of size A is 2 and 4. Okay, so the first output is 2, and when you write this rows comma columns equal to size A, so the first value is stored in the first variable here, and the second value is stored in the second variable here. Okay, and this is the reason you got rows value, it should be 2, and here you go rows equal to 2, and columns here the value should be 4, and here you go columns the value is 4. Okay, so what it means you can store the output of a function in variables too. Okay, now not only this, for example, if I write, let me clear the function first. For example, x equaled 9, right? Now if I want to find the square root, sqrt as square root of 9, okay, x, you got 3 answer. Okay, now you could also write, for example, you can also write like q equaled sqrt of x, okay, and you got the value to be 3. Okay, so when you have only single value of the output, because the square root function only gives how many values in the output, only one value, so you can use this this without brackets, square brackets formula. Okay, but when you got of when the outputs are 2, for example in case of size, okay, then you cannot use this this variable without square brackets. Okay, because then it is going to be a matrix. Okay, so let me show it here. I will show you the error. Okay, so for example, this is our matrix. Okay, now what is the size of matrix? We write size of A. Okay, now I want to store 2 and 4 in the variables. Okay, so I will write, for example, in the wrong way I will show, for example, j comma k equals size of A. Okay, so here you got some very weird things. Okay, so you got j, you get some ans, okay, and then you got k. Okay, so this is the wrong way. Why? Because when you have the the function have two values of outputs, then you don't use what j comma k. Okay, you have to use the square brackets. So let me show you here. I will use square brackets now. Okay, no, not at the end. I have to put the value variables in the square bracket. Okay, now we are good. You will see now j is 2 and k is 4, and this is 2 and 4 because size of A is the first value is 2. Okay, so j should get the first value, right, and k should get the second value of 4. Okay, so in this way you got the correct. Okay, So let us move on. So we are done with this, assigning the output. Okay, now let us talk about nesting of functions. Okay, so what it does, it basically finds, applies function to output of other function. Okay, so let me show you here. So for example, this is our for example, so let me create a variable by the name of a equal to 9. Okay, now I want to find what I want to find square root of sine of 9. Okay, so what it does, it basically what it did, so first it found the value of square root of 9. Okay, the output of sine 9. Okay, and whatever the output of sine 9 is, and then we got the square root of the output of sine 9. Okay, so for example here, let me check the value of sine of 9. Okay, sine of 9 is 0.4121. Okay, now if I apply sqrt here, sqrt of, for example, ans, so you will see 0.6420, and this is the same as here. Okay, 0.6420. Okay, here I applied them together, square root of sine of 9, and here I applied them individually. Okay, for example, first I found the value of sine of 9, here sine of 9, and we got the value to be 0.4121. Okay, then after the value of sine of 9, okay, so the output is what, 0.4121, and then I applied the square root to the output. Okay, so square root of ans, because ans is this, right, output of sine 9, right, so it got me the value of 0.6420. Okay, so this thing is called as nesting of functions. Okay, so when we use, in the parentheses, in the brackets, when we use another function, okay, then what it does, this is called as nesting of functions. Okay, so I hope you got this. Let us move on. So we are done with nesting of functions. Okay, then we have help command. Okay, so it is going to basically tell you, whatever you want to learn about some functions. Or okay, so for example, I need to know about sine function. Okay, so I will write help sine and wait for it. So here to go, it will tell you sine, sine of argument in radians. This MATLAB function returns the sine of element of x. Okay, syntax y is sine x. Okay, so everything you can also see the examples here. Okay, the plot sine function, sine of. Okay, so this help function. Okay, for example, if I write help of help, for example, so it will tell you what the help function does. Okay, help for functions in command window. This MATLAB function displays the help text for the functionality. Okay, so help, it basically tells you, about the functions. Okay, so this is also a built-in function in the MATLAB. Okay, so let's move on. Now documentation is, when you write documentation of tan, it is going to tell you the documentation. Okay, so let me just show you. So for example, if I write doc of, for example, sine and hit enter, now you will see a documentation will open. Okay, so here we get the documentation of sine. Okay, so we got this from mathworks.com. Okay, so here we have y equal to sine x. Okay, so all of these curves about sine function. Okay, so you will see these things. Okay, so this is what we use the documentation for. Okay, so let us move on to other functions. So we are done with the documentation. Now square root, I don't know why I have written here. I have already told you this is a function. Okay, square root early. Okay, so we write this as sqrt, and for example 9, square root of 9, it will give you the square root of 9, which is 3, right? Now also you can apply it to the matrices. So if you write a matrix and write square root, it will give you the square root of each number. For example, let me just show you here. Okay, but I'm sure you understand it already. Okay, so let us say this is a, let me create another. Let us say this is b, 4 16 and 32. Okay, now if I apply sqrt of b, and here you go, you will see 2, 4 and 5 point this, right? So square root of 4 is 2, square root of 16 is 4, because 4 times 4 is 16, right? And square root of 32 is 5 point this, all of this. Okay, so this is how you find the square root of a number or also a matrix. Okay, so let's move on. Now we have this nth root. Okay, nth root is basically, if you want to find, let me show you here. For example, cube root of 9. Okay, so it is going to be 9 power 1 by 3. Okay, so this is what, this is nth root, third root of 9. Okay, so here for this, it is, this x is 9. Okay, and n is 3. Okay, so when you put 9 and 3, it means 9 power 1 by 3. Okay, now for example, 9 raised to power minus 1 by 8. Okay, so because it is 9 raised power 1 divided by minus 8, you can write it like this. So in this case, the value of x is again 9. Okay, again 9, but n here is minus 8. Okay, so when you put nth root, and you will write like this, 9 comma 3, it is going to be 9 power 1 by 3, and when you write 9 comma minus 8, it is going to be this. Okay, similarly, for example, 3 comma minus 2 is what is it? For example, nth root 3 comma minus 2. Okay, so let me write it here. So what is it? It is basically, it will show you the root of 3 raised power minus 1 by 2. Okay, because minus 2 is here. Okay, 3 power 1 divided by minus 2, and 1 minus, we can write it out. Okay, similarly, for example, we can write nth root, for example, 9 comma 3. What does it mean? It means, as I have told you before, 9 power 1 upon 3. Okay, so 9 power inverse of the second. Okay, 9 power, right, 1 divided by 3. Okay, here it is 3 power 1 divided by minus 2. Okay, and here it is 9 power 1 divided by minus 8. Okay, so I hope you understand. So let me just show it in the program. So nth root 9 comma 3, you got this. Okay, why did you get this? Because, you know, the 9 power 1 by 3 is 2. Okay, now let me prove it here. Okay, for example, I will write 9 power, you write power with this caret sign. Okay, and in the braces I will write 1 divided by 3, right? Because this is what the nth root 9 comma 3 means, right? 9 power inverse of 3, right? So 9 power 1 by 3. So here it is 9 power 1 by 3, and we will see if we get the same result. Okay, so here you go, we got the same result. Okay, so this is how we find the, you know, not only the square root, but, you know, the root of any, okay, any n. Okay, so it is nth root. Okay, not the square root, but anything. Okay, including the square root. Okay, so let us move on. So here we have about this nth root. Now exponential is, you know, e to power something. Okay, for example, e to power 2. Now I am not going to show it in the program, it is, you know, very simple. Okay, by the way, the value of exponential is this 2.7 approximately. Okay, 2.7183. Now we have natural log. Okay, what it does, log of x, it means what, log of the number, log of x to the base, what, to the base e. Okay, to the base e. Okay, now when you write log 10x, it is going to show you the log of, for example, log of x to the base 10. Okay, here the base is 10, but in the natural log, okay, when you don't mention the base, the, you know, the MATLAB automatically sets the base as e. Okay, this e. Okay, this exponential e. Okay, now we have rational. Now if you have, you know, if you have a decimal number, okay, you want to find the rational format of it, okay, so you will write rats and the decimal number and you will get the rational. Okay, now factorial, you will get the factorial. Okay, factorial of any number, for example, n factorial is what? It is n times n minus 1 times n minus 2 up to, okay, up to the end. For example, 9 factorial is what? It is 9 times 8 times less than 1, okay, 7, then less than 1 is 6, then less than 1 is 5, then less than 1 is 4, so 3, 2, 1, okay, up to the 1, okay, but it is not going to be below this, okay, because then it is going to be, if we go below 1, then it is 0, right? Then multiplication of all of this with 0 is going to be 0, so the factorial is only up to 1, okay, only up to 1, okay, so n factorial is also up to 1, okay. So how do you find the factorial? You just write factorial n, okay. So let me show it in the program. Factorial, for example, 9. So here it is, factorial 9, okay. 3 6 2 8 8 0, right? So let me prove it like this: 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay. So let us see the answer. So here we got the same result, okay. So now you understand the n, you know, 9 factorial means 9 times 8 times up to 1, okay. So let us also show me the, you know, the rats. I have told you rats show the rational, okay, rational of you know, fractional number. 1.5 is 3 by 2, okay. Rats of, for example, if I write 2 here, so the rational of 2 is only 2 because, you know, it is not the rational number, right? I mean, the, you know, you can write it as a rational number, but the, you know, the denominator is going to be 1, 2 by 1, so it is going to be again 2, okay. So if you write rats of what 3, okay, you will get 3, and if you write rats of 2.5, you should get 5 by 2, okay. And if you write rats of 4.5, okay, you got 9 by 2, okay. So this was the rational numbers, okay. Then I have told you the log. Now let me show you the log and the, you know, natural log and the, you know, this 10, okay, to the base 10, okay. So now let's talk about exponential, okay. So exp, you have to write exp for exponential, not e. So exp of 3 means e to the power 3, okay. So it is this value, but remember the MATLAB doesn't recognize e, okay. So if you write e to the power, for example, 3, it will give the error, okay, because MATLAB doesn't recognize e as exponential, okay. So you have to write exp, okay. Now let us talk about logs. For example, log of 10, it is 2.3026 because it is log of what? 10 to the base e, okay, because when we don't write a number in the base, the MATLAB automatically assigns e as the base, okay. Now if we write log 10 and in the parentheses we write 10, so here it is going to choose base as 10 and you will get 1 as the answer, okay. Then what we had, let me see, okay. Now we have discussed everything, okay, up to this. Now let us move on to combinations, and this one is, you know, interesting, very interesting, okay. So it is nchoosek, okay. So it is n, okay. After that it is choose, okay, like the way, you know, you when you choose something, okay, choose k, okay, n. So you have to choose, okay. Let me change the color here, okay. So n choose k, n comma k. What does it mean? It means, you know, it is you know, in combinations this is the formula, this thing applies here, okay. So what is this? It is basically, you know, when you have n number of items and you want to divide them in k number of subgroups, right? I mean like number of subgroups each containing k items. So how many possibly the subgroups, how many number of subgroups you will get, okay, without considering the order. Okay, so I have explained it here. For example, you have 3, okay, now you want to divide 3, n is 3 here, so you want to divide 3 into how many groups, I don't know, okay, so this will tell you how many groups you will get. So you will tell to the program here, I have 3, n is 3, and I want to know how many groups will be here, such that each group have only 2 numbers. Okay, so it is obvious. For example, you have only 3, so it is, you have how many numbers you have 1, 2 and 3. Okay, so in the first group, because you have told that k is 2, it means each subgroup is going to have only 2 numbers. Okay, any of the 1, 2 and 3, but only 2 numbers. So for example, let us say for the first subgroup is 1, 2, then the second subgroup is 2, 3, and the third subgroup is 3, 1. Okay, so you got 3 as number of possible groups. So here when you write 3 factorial divided by n minus what 2, right, because each group have 2, n minus 2 factorial times 2, so you will get the answer to be 3. Okay, because you will get 3 maximum possible. Okay, also you will not get here 3 comma 1, after that 1 comma 3, because the order does not matter in combinations. Okay, so if order matters, for example 1 comma 3 is also a subgroup, then that's not combination, that is what, that is permutation. Okay, so that is a different thing. Okay, so let me explain this and choose k real quick. Okay, so here we write, for example, n choose k, I will write for example 15 comma 3. Okay, now I will tell you what it means. It means I am telling the program like I have a group of 15 items. Okay, now I don't know, I want to know how many subgroups will I get, such that each subgroup have only 3 items. Okay, now here the order doesn't matter. Okay, so when I hit enter, it is going to show you that 455. Okay, can you imagine, this is a big number. Okay, so you will get, possibly you can get 455 subgroups. Okay, each containing 3 items. Okay, from only one group which have only 15 items. Okay, so initially you have only 15 items in the group. Okay, one group, and you got subgroups as 455 subgroups. Okay, from one group which had only 15 items. Okay, so I hope you understand this. Okay, so it was everything which I wanted to tell you today. Okay, so this was about built-in functions. Of course there are more functions in the MATLAB, but these were the important ones. Okay, so I hope you understand everything. If you have any questions, you can comment, and if you need help in any of your MATLAB project, you can contact me. Okay, so that's it for today. See you in the next class. Thank you.